Let's talk more about this in second slide. So as you can see here, exabyte is the new megabyte. So it clearly means like now there is a humongous amount of data that systems are generating here and there. And I mean, we have a great volume and great velocity for the data that is present in today's world. So let's talk about it in a format like, let's say we have a client IKEA. So they have this many of stores in this many of countries. So they are also generating a data on a daily basis. And based on their data, we can do analysis and all. So their data can be of a structured, semi-structured and unstructured type. And you can just see from here, like they have a 2.5 petabytes of data that is they are generating every hour. So yeah, so that's clearly defines like there must be something extra or something extraordinary that we have to do and to handle this all sort of data. So that's why we have a data lakes in picture. Now let's move to the next slide. Alright, so now the data lakes on AWS, they have multiple source systems. They can be structured, they can be semi-structured, or they can be unstructured. So structured data are like highly normalized. They follows a common schema and resides in a relational database system that support transactional business applications. So they can came from the CRM, LOB applications, they came from databases or ERPs. You can, if you want to think of it in a simple terms, you can think about a CSV file containing an row and columns. Alright, so now talk about the semi-structured data. So this data is characterized by identifiable fields, you can say key value pairs, but yet not bound to a standardized or predefined schema. So it comes in between unstructured and structured data. So you can think about it as in JSON files that we are getting from AWS Kafka, Apache Kafka, or any streaming platform, or if you are getting it in S3, that is also fine. So means you can simply think about it as a JSON file having a key value pairs. Now let's talk about the unstructured data. So data that doesn't follow any particular structure or any schema or anything. So that comes under unstructured data. It can be audio, it can be videos, can be your images. So anything that doesn't have any schema at all, that comes under unstructured data. Alright, so how we can load this type of data? So in general practice, as you might be aware, like can be batch loads or can be streaming. So anything that needs to be run on a daily basis or at a certain time, let's say if we are running a job at 9 UTC, it's a fixed time that we have to start our job on a daily basis like that. So that comes under a batch load. So we extract the data from various data sources at periodic intervals and then move them to the data lake. So you can think about it like a PySpark job running on a EMR, or it's a glue job that is running on AWS. Alright, so same thing for streaming. So we can think about it like a sensor data that is coming in a near real time, or if you can go to the previous slides, then you can say like they are getting a 2.5 petabytes of data every hour. So that is also a streaming problem if we need something that needs to be analyzed in a near real time. So for that we are getting a data from Amazon MSK, which is nothing but Apache Kafka, and they have a in-house capability as well. So that is Amazon Kinesis. So these two can be used to ingest the streaming data. So once everything is done, all the transformations are done and all, so we are ingesting the data to the Amazon S3 data lake. Why we selected a data lake S3 as a final target for the data lake? Because it's scalable. You can say it's a scalable service that we have in Amazon, and it can store a structured data, unstructured data, and semi-structured data without any issue. Think about it like a file explorer on your Windows laptop. Alright, so once the data is there, there are functionalities that are available in AWS. We can do analytics on top of this data. For that we can use a Redshift, that is our data warehouse, and we can use Athena on top of this S3, and we can also do some visualization, run some visualization tools. We can create a graphs and all by using this Amazon quick site. All right. Similarly, we can have a machine learning wherein we can use the EMR clusters to trigger our machine learning jobs. We can use a SageMaker, and we can use a AWS deep learning AMIs. Okay, let's jump on to the next slide. Okay, so what exactly is the difference between data warehouse and data lake? So this is a general question that you might be hearing here and there. Like if we have a data lakes, then we already are aware like we have a data warehouse as well. So why we need a data lakes? There must be some difference. So let's talk about it now. All right. So data warehouse, you can say like it's a data first, load later. What does that mean? So you define the schema beforehand, and then after you can load the data, so you know what you are adding into your data warehouse tables. Okay, but in data lakes we don't define any schema. Wherein whatever we are getting, we simply load it into our data lake, and we then understand it later. We define our schema based on our needs. We can define the schema, but we let everything be in the data lakes. Okay, so data warehouse can store a relational data. We can say like a structured data that has a predefined schema. But in data lakes, we can store everything, can be structured, semi-structured, or unstructured. So if you talk about the schema, then it's a schema on write. So whenever we are writing, we should have a predefined schema defined on that. But here we are dumping everything here, and then while reading, we decide like, okay, we have to read these fields and all. So if we talk about the data quality, then it's highly curated data that is available in the data warehouse. Means that data is actually powering all the analytics operations for the business. So that's why we need a data warehouse. But in data lake, we are simply storing the data that is coming to us as is from the streaming or batch platforms. It can be a raw data, unstructured data, and many other formats like semi-structured data as well. So if we talk about the flexibility, then in data warehouse is relatively difficult to change as the data is highly structured. We cannot, if we have to change the schema and all, we have to change it in a table. We have to make the changes in our consumer views. We have to communicate those changes and all. So it's a process. It's a development process that we have to undergo. But in data lakes, simply we have to dump the file. It automatically adapts the changes easily as the requirements evolve. We will talk about it later. Now we say the users. We have operational user like business BAs sitting on the data warehouse that are running their jobs and all. So that's why we have a data warehouse. And in data lake, we have all kind of users, data scientists, analysts, or business analysts that want to analyze the data that is coming into our system. We talk about the performance. We have a faster query results because we know the table structure and all. I can see data lake as less performant uh, because we are using the indexes and catalogs. But yeah, we have some mechanism as well in AWS Glue where we can do the data cataloging and all. So it provides a flexibility as well in terms of schema, but you can say it's a less performant than this data warehouse. So there is a trade-off, but yeah, overall that's what we have as a difference.